Welcome to Summarize Science. Have you ever noticed how people in movies or online videos sometimes look like they were poorly pasted onto a fake background? The main reason is that the lighting on the person often doesn't match the lighting of the new scene. The research paper we are looking at today introduces HarmoVid, a framework designed to fix this problem for good. Usually, fixing a single photo is easy, but videos are much harder because things are constantly moving. If you try to adjust the lighting frame by frame, you often get a distracting, flickering effect where the brightness jumps around. Another problem is that it is almost impossible to find real-world data to train an AI on this, as you can't record a person doing the exact same movement in different lighting setups. To solve this, the researchers created a two-stage training strategy that uses both real and synthetic videos. They first built a lighting deflickering network that acts like a stabilizer for light. This ensures that as a person moves, the shadows and highlights on their face change smoothly rather than jumping. The second stage involves the HarmoVid model, which learns how to blend the person into the background realistically. This system uses a three-step pipeline to process data, refine it, and then train the final video harmonization network. The model is based on a 3D transformer architecture, which is a type of advanced AI that can understand both space and time. It takes the person, the mask showing where they are, and the new background to predict exactly how the light should fall. This approach allows the model to handle very complex lighting transitions and even local shadow changes. One of the cleverest tricks used is called an asymmetric alpha mask. This helps the AI learn how to create soft, clean boundaries around things like hair, which are usually very hard to cut out perfectly. By learning from real videos, the system discovers how light naturally bleeds around edges for a more convincing look. When compared to existing tools like IC-Light or Light-a-Video, HarmoVid consistently came out on top. Looking at the data tables, it achieved higher scores for both image quality and how well it preserved the person's identity. In a user study with 33 participants, the results from this method were preferred nearly twice as often as other leading techniques. You can see the difference clearly in these side-by-side comparisons. While other methods create weird blue tints or ghost-like edges, HarmoVid keeps the person looking grounded in the environment. Even when the background lighting is very dramatic, the person's shadows and skin tones adjust in a way that feels physically correct. The researchers also found that the model works surprisingly well on non-human objects, like the camel shown here. This demonstrates that the AI has a general understanding of how light works, not just how faces look. They also proved that their specific two-stage process was essential, as skipping any part led to much worse results. To recap, HarmoVid solves the flickering issue and the training data shortage to create highly realistic video composites. The key takeaways are the use of a deflickering network and a dual-path learning strategy that bridges the gap between real and fake footage. This technology could mean that in the near future, anyone with a phone could create Hollywood-level special effects. It will likely transform everything from social media filters to virtual reality and remote work meetings. Thanks for watching Summarize Science, and don't forget to subscribe for more deep dives into the latest research.